If you can tell from the title of my presentation, I'm going to be talking about how we used big data to keep a very specific project moving forward during the COVID-19 pandemic. And HDR was the lead design consultant for South Carolina Department of Transportation and their project to replace the US 321 locally named Elmwood Avenue Bridge in downtown Columbia, South Carolina. I do also want to mention that there were several sub-consultants on the team that are serving in various capacities, but I want to give special mention to Ramey Kemp and Associates, who were a sub-consultant that were handling our traffic microsimulation modeling. And so they were very instrumental in this early phase, and they were right there with us as we were trying to navigate how we were going to get data. To give you a little bit of background on the project itself, this is a picture of the bridge location, and if you can tell, it's really located within the downtown core of Columbia, South Carolina. The lower right corner of the screen, you can see a blow up of the bridge location, which is shown in yellow, and you can see that it's very close to, it's really adjacent to an interchange, which is the terminus of Interstate I-126 here on the west side of the interchange, which is a freeway that is serving downtown Columbia and connects with downtown Columbia with Interstate 26 further to the north and west. It's a very challenging location, and because of its proximity to the freeway, it's carrying about 50,000 cars a day per 2019 South Carolina DOT traffic counts. But nevertheless, it was a very difficult bridge to have to replace. It's 6 lanes wide, and the real goal was to try to keep the bridge open during construction to minimize delays for the general public. And really, as you'll see pretty soon, one of our big tasks was trying to evaluate what the best strategy for maintaining traffic during construction staging was going to be. So we looked at several alternatives. The scope for phase 1, as I just mentioned, was evaluating several maintenance of traffic options. We determined that there are potentially 4 reasonable options for us to evaluate. We were also, as a team, tasked with developing a construction method for replacing the bridge and developing preliminary structural plans for the bridge deck and its alignment as well. I'll be focusing on the evaluation of the maintenance of traffic options here, though, today. So, as I mentioned, this project was impacted by COVID-19. However, when we first started scoping this project, it was, towards the end of 2019. And at the time, our scope included counting 20 locations. Those are intersections and where we were gathering turning movement counts for AM and PM time periods. We were also looking at vehicle and classification counts on the ramps to that interchange. We also wanted to make sure that we were gathering pedestrian and bicycle counts in proximity to the bridge. And the reason why that was important is that the bridge actually spans an abandoned rail line that's been converted into a pedestrian and cyclist walking path. So it was important to make sure we understood what that activity looked like there. And developing an origin and destination matrix for our microsimulation modeling was another very important task in phase 1 of this project. And I'll pause and mention here too that for us to do this with the study area that we were working with, you can kind of see from the image in the background that it's a dense urban core. There are countless number of grid streets shown here. And these are actual representations of the zones that we set up using StreetLight to help us develop this origin and destination matrix. And so we were initially, before the pandemic even started, we were planning to use StreetLight Data to help us with this project. It actually ended up being very fortunate that we did, which I'll talk about in a minute. And so once we had that information, so once we had the origin destination matrices and all of the volume counts that we were planning on collecting, we would then pass that on to Ramey Kemp and Associates, who would then create and calibrate our microsimulation model, which we were using Transmodeler for this particular effort, and then using that to help test 4 variants of our MOT staging. Those, if you're interested, we were looking at what traffic would do during a full closure of the bridge. We also looked at alternatives where we reduced the number of lanes on the bridge and kept some open to traffic. So we looked at a 4-lane section, a 3-lane section, and a 2-lane section as well. So as I've mentioned, and as you picked up by now, the project was definitely impacted by COVID-19. You know, it was February 2020. We were getting ready to begin our data collection phase. And suddenly we were hit with the lockdowns that the nation faced, and we were just not able to go collect traffic data. No one was driving, and I don't even think if we went out and tried to count today, we would get pre-COVID numbers, which is really important because, you know, as we're doing and making these projects and designing for these projects, we want to make sure that we are considering a time frame in which, you know, activity has returned to some semblance of normal. We were also concerned with how are we going to calibrate the model, and I'll speak to that a little bit later. So very early on, just to illustrate why this was such a problem for us, this is a map of the study area, and the intersections that you see circled in yellow are locations where, after we did an inventory, we found that we did not have any data that we could procure at these locations from counts that we had internal at HDR. So we started looking at outside resources, and we approached South Carolina DOT and other consultants who had done work in Columbia. And we were able to actually identify a few projects that had happened in the last 3 to 5 years where we were able to take data from those sites. So we were able to actually fill in some of those gaps using that information, but we were still left with, as you can see, quite a few locations that were still missing. The next step in this process was to identify and reevaluate which ones of these locations were actually critical for us to get a model built. And we ruled out, you know, the use of the bicycle and pedestrian counts. We decided that that wasn't critical for us to keep moving on the traffic analysis. We can go back and try to count those at a later date. And so we were able to then rule out a few more locations. But what you're seeing now on the screen in the remaining circles are the locations where we had no data with which to build our models from. And I want to point out that this road that runs north-south along the screen here is Gadsden Street. And this is a very important road to how traffic is moving through downtown Columbia, because it's a little hard to tell, but when you're driving in on 126 off of the freeway, Gadsden Street is the first location where you can take a turn and reach some of these interior destinations of downtown Columbia. And so there's a lot of traffic moving on that road, and we just had no idea what was happening here. And that was a big problem and a big setback. So we started asking ourselves, well, what can we do to fill in the gap? And the thing that came to mind right off the bat was that we have access to a Streetlight subscription for this project, because as I mentioned, we were already planning on collecting origin and destination information to model. Can we use that platform to help us approximate turning movement counts? And so we reached out to South Carolina DOT, and we spoke with the project manager for the project, and we spoke to the Office of Traffic Engineering, and we started coming up with a plan for ways to fill in those gaps. One of the big questions was, how reliable are these counts compared to field collected counts? Because we know that Streetlight Data does do validation checks, but we were saying to ourselves, is it valid in Columbia, South Carolina? Is it just valid in the locations where they have done the validation checks? We need to answer that question to make sure that we can move forward. And so what we did was we developed a comparison process where we used information that was publicly provided by Streetlight in some of their white paper research documentation to do our own comparison. So we had counts from a similar nearby project that was done in 2019, and we did a comparison using statistical checks on that. And we were able to actually determine that this information is a very reliable stand-in for the information that we were missing. And so we concluded that we were able to use this as a source and keep moving. This is an image of the platform of the Streetlight web platform itself. And I won't go into too many details, but I did just want to kind of illustrate, how we went about doing this. This is one of the intersections right here that we needed to count. And our traffic engineers were able to use Streetlight to set up small origin destination zones across each leg of the intersection. And from that, we're able to actually generate turning movement counts in a very easy and quick method. We have them for peak hours, but we could also have them for multiple hours of the day or even a full day if that was needed. And taking that information, we then use that to fill in our volume development spreadsheet. I know this is pretty hard to see, and I'm sure you can't read any of this text on here, but I just wanted to make the point that this box here is one of the intersections that was counted by the Streetlight Data platform. And it became very easy for us to take the turning movement counts that we received from the platform, insert this into our master volume development spreadsheet that we had built for the project, and very quickly and easily balance those counts with other upstream and downstream adjacent intersections in the study area. So this is a very seamless process, and really didn't take any additional time than what it would have normally taken for us to do this step. This is an example of the matrix that I was speaking about before, and I just wanted to show this. This was another piece of the puzzle, I guess, so to speak, of getting a completed model calibrated. And as you can see here, these pink columns and these pink rows represent external zones. So these are locations where traffic might be entering or exiting our study area. And we basically set up a zone across each road that entered or exited the area immediately adjacent to our project. And we developed 10 internal zones as well to capture trips to and from destinations within our study area itself. And so using those two pieces of information, we were able to then pass that along to Ramey Kemp and Associates and let them begin developing their microsimulation model to help create those MOT scenarios that we talked about in the beginning of the presentation. So I'll just wrap up here and just describe a little bit about where the current, what the current status of the project is, and talk just to conclude about how the Streetlight Data helped us reach that status. We're currently on schedule with the project. We are finalizing and refining several of the MOT scenarios to advance for further evaluation. And by having those MOT scenarios and having the ability to simulate those now, even during the spring and summer and fall of 2020, we were able to give information to our roadway and bridge engineers to make decisions on construction methodology and staging decisions, and really keep them moving with their designs components of phase one. And all of that, really, I don't see a way that we could have done that without the ability to use big data to help fill in some of those gaps.